Good afternoon, good morning, good night, whatever time of day it is when you guys are watching this video. Today we're going to talk about Avogadro's number. Okay, this is something that you have looked at before. It's the 6.02 times 10 to the 23rd, but we're going to now really use it. Okay, what does that number really mean? So there's two things we're going to do today in this video. We're going to compare two samples using the mole concept. We're also going to use Avogadro's number to convert between moles and number of particles. So now we're going to talk about an amount without counting them. Okay, so remember, a dozen is 12, a ream is 500 pieces of paper. Okay, so those are conversion factors. So let's take a look at this penny. How many atoms do you think are in this penny? Obviously, you are not going to sit there and count them because we can't even see one single atom. What we can do is relate it to a mole, which then again, we can relate it to mass, because mass is something that we can relate to. So if we take a look at a mole, the mole, again, is my counting unit. 1 mole is equal to 6.02 times 10 to the 23rd. So if I have 1 mole of anything, I have 6.02 times 10 to the 23rd of those things. So if I take a look at my donuts and my giraffes again, and I know I've asked you this question before, if I have 1 dozen donuts and 1 dozen giraffes, how are these two things similar? Hopefully you said it's the same amount. I have 12 dozen donuts. I have 12 dozen giraffes. Same thing with a mole of donuts. I have 1 mole of donuts, 6.02 times 10 to the 23rd, and 1 mole of giraffes, 6.02 times 10 to the 23rd. I have the same amount. Okay? But remember when we talked, how are these two things different? Hopefully said they are different by their masses. 1 donut does not have the same mass as that cute little baby giraffe. So if I take a look at this H3PO4, how many molecules are in 1 mole of H3PO4? Well, since I said mole, and I'm asking for molecules, you should know I'm asking for an amount, okay? Well, 1 mole is equal to 6.02 times 10 to the 23rd. So I have 6.02 times 10 to the 23rd H3PO4 molecules, okay? Oops, sorry guys. So now let's take a look at this one. If I just had 1 molecule of this H3PO4, how many hydrogen atoms are in this molecule? Your answer is 3. How did I determine that? It's my subscripts. How many phosphorus atoms are in 1 molecule? My answer is 1. How many oxygen atoms are in this 1 molecule? It's 4. Okay. All I'm doing is if I just have 1 of these, I have 3 hydrogen atoms, 1 phosphorus, 4 oxygens. So now, what if I ask the question, if I have 1 mole of H3PO4, how many hydrogen atoms do I have? Okay. Well, if I have 1 mole of H3PO4. Now you got to be careful with terms on this, okay? I'm trying to get rid of moles of H3PO4. How many moles of hydrogen atoms do I have? If I have 1 mole of this, how many moles of just hydrogen atoms do I have? I have 3. Okay. And now I'm asking for not just number of moles, I'm asking for how many hydrogen atoms. So in 1 mole of hydrogen, I have 6.02 times 10 to the 23rd. Ooh, I'm running out of room, guys. Okay, so now I just do 1 times 3 times 6.02 times 10 to the 23rd. Then I'll get me the number of hydrogen atoms in a mole of that. So let's take a look at this one. If I have 1 mole of H3PO4, so again, how many hydrogen atoms? Okay, in 1 mole, I have of H3PO4, I have 1 mole of phosphorus. And then in 1 mole of phosphorus, how many phosphorus atoms do I have? I have 6.02 times 10 to the 23rd. So in this case, I have 6.02 times 10 to the 23rd phosphorus atoms. How many oxygen atoms would I have? Hopefully you said